CAN bus communication is widely used in the transportation industry where reliable transmission of data is paramount. Monitoring and recording these communications are useful to testing and validation engineers for ensuring proper system performance. Hey, I'm Cameron Simpson, an applications engineer with Yokogawa Test&Measurement. Today, I'll be showing how to integrate low-speed CAN bus data with high-speed 200 megasample per second analog data using our DL950 ScopeCorder. For our example, we're going to expand the capabilities of our data acquisition system using a CAN-based wireless thermocouple amplifier from Texense. I will demonstrate high-speed capture of a 20 kHz motor inverter while monitoring the low-speed output of Texense's wireless temperature sensor. I'll also be using an industry-standard DBC file for integration with our ScopeCorder using our symbol editor software. The DL950 with the VCE option accepts modules compatible with CAN, CAN-FD, LIN, and sense signals, and up to 240 CAN channels from 4 buses can be read by a single instrument simultaneously. These channels can be recorded as trends alongside the high-speed channels of the DL950, and you can choose any or all of those CAN bus channels as your trigger source. Our demonstration today uses the output of this motor drive, which is then connected to a 3-phase brushless motor. The current output of this drive will go through a current clamp to the input of our ScopeCorder on channel 1. We'll also be monitoring the temperature of the motor using this wireless thermocouple amplifier from Texense with a K-type thermocouple. The wireless receiver for this sensor will connect to the CAN input of the DL950. The CAN modules we're using should only be installed in slots 7 or 8 of the ScopeCorder. Lastly, we'll want an industry-standard DBC file with message definitions for the CAN sensor. Now, we'll load the DBC file for the Texense sensor into our symbol editor software to perform a simple conversion to the SBL file for our DL950. This software is available for free on our website, and a link will be provided in this video's description. Launch the software, ensure the edit mode is in CAN/CAN-FD, and press File, then Reference to load your DBC file. Choose your file from the File Explorer, and then press Open to load it into the reference list. Select the messages that you want to add to your symbol file, and transfer them to the Define list using the Add Define button at the bottom. When you have transferred all of the message definitions, you can create the SBL file by pressing the Save Define button at the bottom. On the DL950, we can now load the file produced in the symbol editor. First, press the CH button on the device's front panel and press one of the CAN bus channels to select it. These will be among channels 13 through 16. In the channel's soft menu, press CAN port configuration to open the CAN setup menu. Press symbol file load, select the SBL file saved earlier, then press execute load to confirm your selection and load the file. Next, I'll show how to adjust the trigger settings to respond to our CAN bus signal. Press the trigger menu button on the front panel and select the simple trigger setting for a single source trigger. Now choose source and select the CAN input channel, which for us is channel 15, and select the subchannel you wish to trigger on. From this menu, you can adjust any other trigger settings like slope, level, and hysteresis as desired. Our temperature channel is expected to change slowly over time, so we'll set our trigger mode to auto to show the long-term trend. We'll now press the start button on the front panel and start the motor kit to begin the test. While the unit shows the temperature trend of our CAN data, we can zoom into the high-speed waveform by pressing the zoom button on the front panel. Using the adjacent zoom knob, we can adjust the window to show the current waveform with better clarity. We can observe the temperature rise from the motor drive at shutoff to equilibrium of about 35 degrees Celsius. Once we've verified our data was captured correctly, we can then save the waveform to the device's internal memory by pressing File, then Save Waveform, and then Save Execute. This waveform can now be accessed for further analysis at a later time. That's all for today's demonstration. In summary, I introduced the CAN function of the DL950, showed how to create your own symbol files from DBC files using our symbol editor software, and demonstrated the process of adjusting CAN module settings on your DL950 to capture and decode CAN bus signals. Please check out the manuals on our website for help with setting up the devices used in this video, and visit Texense.com to learn more about their sensors. Additionally, a link to the updated firmware for the DL950 can be found in this video's description. For more information, please visit tmi.yokogawa.com. Thank you for watching.